Hi, my name is Catherine, and I'm with Calvin, Afosu, and Victor, and we are Group 5 Mastery Learning Data to Predict Course Performance. To introduce our project, Mastery Learning is a classroom structure that allows students to master one topic before moving on to the next. So this would include their own pacing and also allowing multiple attempts. For our project, we'll examine Professor Lip's graduate programming course, ECE 551, which uses this structure. Our objective for our project is to develop a predictive model to identify struggling students in this class as early as possible, even before the first exam, so that we can provide intervention and aid overall success.
As you can see, this is a high-level architecture of our system, from fetching information from the backend database of the Mastery Learning platform, the data going through a series of transformation and then ending up in a local facility, which is an SQLite. So we get a process features from our local database, get predictions from our best model, do the interpretations of the predictions, and then we display accordingly. As you can see, this is how we simulated the backend database of the Mastery Learning platform. This is a typical table for grades. We fetch information from this table, and then those data ends up as features in our SQLite database.
Some of the features present here are features that we generated on our own from the raw data. For example, there's a feature here for snowballing, which is basically the number of consecutive days that a student submitted late. Another big feature that we conducted was a quote-unquote outlier scoring model. This is more of a rules-based model rather than a mathematical one. The way it works mainly is that it goes through the data set feature by feature and analyzes each feature by a few different basic characteristics. For example, it mainly measures whether the outliers are more common within the struggling group than the non-struggling group. And when features show these prominent characteristics within the struggling group, for example, when a struggling group contains more of the outliers, then we use this to predict a score for each person such that when a person is an outlier within a feature, it adds to their score, and this score is totaled among all features within the dataset. By engineering this outlier scoring feature and other features from the raw log data and grade dataset, we were able to create accurate predictions for who will struggle, despite only having 55 students in our training dataset.
So we got the data augmented with Calvin's, and our original data had 9 struggling and 46 non-struggling. We used synthetic minority oversampling technique to get equal numbers, and from that we used PCA to keep only 95% of variance. We didn't want to have too many columns and not to have too little columns, so we used PCA to get a good number of columns. We inputted that into our models, so we used 20 unique models with a total of 46 variations. We trained them and organized them by F1 score, and we built an ensemble of models using our 5 highest F1 models if they had the required functions and were not overtrained, defined as F1 as a 1.0 score. And on the right, you can see our receiving operating curve for that. It has a score of 0.95. You can see that's a great model. And at the bottom, you can see the scores we had all above 0.87, which is not ideal, but remember we only have 55 unique data points. So these are actually quite high when we consider that. Lastly, we used 5 models, so random forest, cat boost, his gradient boosting, Ada boost, and gradient boosting. They were all unique, and that's why we decided to use them.
Our usage of the system, the user gets the options to see the available commands of the system. The user can do predictions, get the predictions, and then decide as to how to view those predictions. Do we ask whether he or she wants to send alerts to students, and then voila, the system sends alerts to the student.
While we worked on our model, we also did some research in parallel to help inform the implementation of our project. In doing this, we have created some recommendations of the characteristics of the feedback that the instructor should give the students once the struggling students are identified. Some of these feedbacks include customized responses, a conversational tone, and also feedback that demonstrates utility value. Studies on college courses of a similar difficulty have shown that feedback with these characteristics resonate more with students and overall increases course performance. Thank you for listening.